Our question today is, how does the center of gravity apply to stability? The center of gravity is defined for an object as the point located at the object's average position of mass. We a lot of times refer to the center of gravity as the center of mass as well. So if I use those words interchangeably, they mean the same thing. So again, it is the point located at the object's average position of mass. When you throw something, the object will rotate around its center of gravity, which is abbreviated as COG. For example, the centers of mass of the baseball and of the spinning baseball bat each are going to follow the parabolic paths. That is that name of the curve here that they follow. Okay, so it's not necessarily the end of the bat that follows that trajectory, but instead it is the center of mass or center of gravity of the bat that is going to follow that trajectory. So both of them will follow this parabolic path if we look at only its center of mass or center of gravity. However, the bat also spins around its center of gravity. So when it spins, the point around which it spins is the point referred to as the center of gravity. So as this spins around, this point that it spins about is called the center of gravity. For a symmetrical object, such as the baseball, the center of gravity is at the geometric center of the object. You can measure its length or width and simply divide by 2, and therefore locate the center of gravity. For example, if we take a meter stick, and a meter stick is 100 centimeters long, if we divide that by 2, we find that the center of gravity is located at the 50. That is for a symmetrical object, an object that looks the same on both sides of the center. But for an irregularly shaped object, such as the baseball bat, the center of gravity is going to be towards the larger end. It's not in the middle. It's not that we can just take the total length and divide by 2. Instead, it's going to be shifted towards the heavier end of the bat. For example, if we look at this triangle here, the center of gravity is not in the geometric center. Instead, it is shifted downward towards the bottom part, since more mass is on the bottom than is on the top. And again, this whole idea of center of gravity is saying that there is the same amount of mass below as there is above. There's the same amount of mass on the left as there is on the right. Same thing with the cone. Center of gravity is not in the geometric center. We can't simply take the total height of the cone and divide by 2. Instead, that center of gravity is shifted towards the heavier end, since there's more mass at the bottom than there is at the top. Now, some objects can have the center of gravity outside of its actual material. So, for example, a boomerang here, we see that the center of gravity is right here, but there is no material at that spot. But at this location, there's an equal amount of mass on the left and the right. If we divide it this way, there's an equal amount of mass on this side as there is on this side. Same thing with a horseshoe. The center of gravity is outside the actual material. There's an equal amount of material on this left side of the horseshoe as there is on the right side of the horseshoe. And here, if we look up and down, there's an equal amount of material below as there is above. And so the center of gravity is not actually on the object itself. Same as like a donut, or maybe a tire that's open in the middle. The center of gravity is right in the middle. It is outside the material of the object. Now, how does this all apply to stability? Stability is things falling over or not falling over. Now, an object will remain upright until its center of gravity moves beyond its leading edge or base. So the base of an object is the part in contact with the floor or table. So this base, the the base of this object here, this rectangle, is this part here, the part touching the table. Here's our center of gravity. And if we draw a line straight down, we see that it's over top the base, and therefore it is considered stable. In this picture here, this scenario, the center of gravity is still over the base. And here's the base of the rectangle. So center of gravity is still over the base, and so this object won't fall over. Instead, it will go back to the way it used to be. However, here's the point of no return. At this point here, the center of gravity moves beyond that base. And once it moves beyond the base, or leading edge, the edge is, the corner. Once it moves beyond that leading edge, then it tips over and falls. An application of the center of mass, or center of gravity, would be the Leaning Tower of Pisa, which has been leaning since 1173 AD. It's leaning because of poorly constructed foundation. It was not built upon a very firm surface, and so this side started to sink, and so it's leaning. However, if we look at the center of gravity, which is going to be somewhere around this spot here, it is still within the base of the tower. And so the tower is not going to fall over until the center of gravity is no longer above this leading edge right here. Once this line moves beyond this point, that's when the leaning of tower would fall over. So it's fairly stable because that center of gravity is still well behind the leading edge.